In the coding lab that you see in this module, you play with a chart generation workflow where you use an agent to generate nice looking diagrams. And it turns out reflection can significantly improve the quality of its output. Let's take a look. In this example, I have data from a coffee machine showing when different drinks, such as a latte coffee or hot chocolate or a cappuccino coffee and so on, were sold and for what price. And we want to have an agent create a plot comparing Q1 or first quarter coffee sales in 2024 and 2025. So one way to do it would be to write a prompt that asks an LLM to create a plot comparing Q1 coffee sales in 2024 and 2025 using the data stored in a spreadsheet as a CSV file or comma separated values as a spreadsheet file. And an LLM might write Python code like this to generate a plot. And with this V1 of the code, if you execute it, it may generate a plot like this. When I ran the code that the LLM output, it actually generated this the first time. And this is a stacked bar plot, which is not a very easy way to visualize things, and it just doesn't look a very good plot. But what you can do is then give it V1 of the code, as well as the plot that this code generated, and feed it into a multimodal model that is a LLM that can also accept image inputs, and ask it to examine the image that was generated by this code, and then to critique the image, find a way to come up with better visualization, and to update the code to just generate a clearer, better plot. Multimodal LLMs can use visual reasoning, so it can actually look visually at this figure to find ways to improve it. And when I did this, it actually generated a bar graph that isn't this stacked bar graph, but a more regular bar graph that separates out the 2024 and the 2025 coffee sales in what I thought was a more pleasing and clearer way. When you get to the coding lab, please feel free to mess around with the prompts and see if you can get maybe even better looking graphs in these. Because different LLMs have different strengths and weaknesses, sometimes I'll use different LLMs for the initial generation and for the reflection. So for example, you may use one LLM to generate the initial code, maybe OpenAI's GPT-4 or GPT-5 or some model like that, and just prompt it like a prompt like this to write Python code to generate visualization and so on. And then the reflection prompt might be something like this, where you tell the LLM to play the role of an expert data analyst that provides constructive feedback, and then give it the version 1 of the code, the plot that was generated, maybe also the conversational history from how the code was generated, and ask it to critique it for specific criteria. Remember, we give it specific criteria like readability, clarity, and completeness. It helps the LLM better figure out what to do, and then ask it to write new code to implement your improvements. One thing you may find is that sometimes using a reasoning model for reflection may work better than a non-reasoning model. So when you're trying out different models for the initial generation and the reflection, these are different configurations that you might toggle or try different combinations of. So when you get to the coding lab, I hope you have fun visualizing coffee sales. Now, when you're building an application, one thing you may be wondering is, does reflection actually improve performance on your specific application? From various studies, reflection improves performance by a little bit on some, by a lot on some others, and maybe barely any at all on some other applications. And so it'll be useful to understand its impact on your application, and also give you guidance on how to tune either the initial generation or the reflection prompt to try to get better performance. In the next video, let's take a look at evals or evaluations for reflection workflow. Let's go on to the next video.